Hello and welcome back. And what we have here is another difference quotient, this time for a radical function. So as usual, all we're going to do is substitute what we need to here. So in our difference quotient, we have f of x plus h minus f of x all over h. So we just need expressions for f of x plus h and f of x. Well, we were given f of x equals the square root of x plus 3, so that part just goes there. And for f of x plus h, remember that that means that we are replacing x with x plus h, which gives us, in this case, x plus h plus 3, and that's all over h. So at this point, what do we do to simplify? Because it looks like it actually is pretty simplified. But remember, with a difference quotient, the goal is to get the h out of the denominator. We want to rewrite this expression so that the h's cross out. So this one involves a technique that you may have learned in your algebra experience. We're still going to multiply by a fancy 1. But when we deal with radicals, we're going to multiply by what's called the conjugate. And the conjugate of this radical expression here that I'm going to put in brackets is basically the same terms, but with a plus sign in between. So we're going to have square root x plus h plus 3 plus square root x plus 3. And I'm going to multiply that to the numerator because that's where I need it. But whatever I multiply to the numerator, I have to multiply to the denominator as well. So when we make that multiplication, let's see what happens. The first thing to note is, since I want the h to cross out, I'm going to leave the denominator in factored form. I'm not going to multiply it out. So I'm going to have h times the square root of x plus h plus 3 plus square root x plus 3. Now in the numerator, we basically have a binomial times a binomial. So if we take the first times the first, remember that a square root, I'm just going to write over to the side here, a square root times itself just gives you the radicand, or the number inside the radical. So this is just going to be x plus h plus 3. And if you notice, if we multiply the outers and the inners, those are going to be the same expression, but one's going to be positive and one's going to be negative. So that means when we combine them, they're going to cancel out. So I'm not even going to bother writing that. And then for the last times the last, we have the negative square root of x plus 3 times the positive square root of x plus 3. So that's going to be minus x plus 3. Because again, when you multiply the radicals together, you just get the inside. So now it looks like we're getting somewhere. So we're going to simplify the numerator, and up above it, I'm just going to write x plus h plus 3 minus x minus 3. And what you notice is everything cancels out except for the h. So we have equals h divided by h parenthesis square root x plus h plus 3 plus square root x plus 3. And the h's cancel out. And it looks like our final answer is 1 over square root x plus h plus 3 plus square root x plus 3. Now, our mathematical training tells us that we shouldn't leave radicals in the denominator, but this is going to be one case where it's allowed because it's more useful. And when we get to the next unit, we're going to see exactly why.